Good morning to all. Today we can discuss about the current series feedback amplifier analysis. So, on the subject analog electronics. So, as you all know that there are topologies of feedback amplifier. There are four topologies. So, these four topologies, what it indicates is it is based on the basic amplifiers such as voltage, current, transconductance, and transresistance amplifier. So, this particular is based on how this voltage amplifier and your feedback networks are connected. So there is voltage amplifier with voltage series feedback means it will be having series mixing and voltage sampling. Like so, voltage amplifier is used to amplify input signal and provide amplified input voltage at the time, as you know. So likewise, you have current amplifier with current shunt, then transconductance amplifier with current series feedback, trans resistance amplifier with voltage shunt feedback. So these are the four categories of feedback topologies. So they based on this four feedback topologies, today we are going to discuss about the analysis of current series feedback. So, current series feedback is based on the current amplifier. So, based on the current amplifier, it is going to. So, this is the circuit for the current series feedback amplifier. So, there is a so how it is going to be identified is it is going to identify based on the type of mixing and the type of sampling. So mixing will be in the input side and sampling will be in the output side. So the type of sampling is current sampling. Why it is current sampling is because the it is going to be using that is having the output feedback current amplifier, the feedback network in the output side is connected in series, so that is considered to be the current sampling, and the feedback will be depending on, since the current flow from this emitter, the current flowing through from this emitter is going to be opposite to the output current. So Vf is equal to minus I naught into Re. So the type of mixing is series mixing. What series mixing represents is the current amplifier and the feedback network will be connected in parallel in the input side. So this will be, so we can say this, see this output is does not, this input side source is not having any connection with the feedback network. The feedback network is thus not having the connection from the to the input side. So we can say it is a series mixing. Or similarly, the output voltage is not taken across the feedback network. So the output voltage is not taken means across the feedback network, but it is taken from the collector of the transistor. So it represents is taken from another one terminal. So it follows current sampling. This is one shortcut to find which type of sampling or which type of mixing. So as per this diagram, it is going to be the current series. Okay. So that is the actual first step in the analysis, identification of topology. So it is a current series topology. Second step is to draw the input circuit. So from the input, so input will be to the base of the collector, right? So from that, it is connected to, who are all connected to the input will be allowed on. So I naught, the output current is zero means, so in this case, the output current is zero means you will be getting only this part. So this is only your input side part. So this is your input side. So draw the input circuit. So RE appears at the input side, the feedback resistance because the feedback circuit should present in all both the input circuit and the output circuit. Okay. Step 3 is draw the output circuit. So input current is zero for series mixing. So the output side alone you have a collector resistance. So I told you the feedback should be present in both the input circuit and the output circuit. So the feedback resistor will form now, since you are put supply voltage VCC is made zero since IA is zero, input current is so output current is zero. So this will be your output side circuit. So output side also has what are the things it will be having is one your output side collector as well as your feedback resistance. Okay. Next, combine both the input circuit and the output circuit. So now combine your input. This is your input circuit and output circuit. So now you have seen as per the diagram, you have how many how many feedback resistors? Two feedback resistance as it is common to both input and the output circuit. So combinedly you draw this both the input and output circuit. Step 4 is you have to draw the H parameter model for the above circuit. So H parameter model means you have to replace the transistor with the input resistance, transfer resistance HIE and the current source HFE IB. So as you know, this is your H parameter model for the transistor. So you have a supply voltage and you have the input RS, RE. So in the transistor alone, you are going to replace by your HIE, this transistor is alone replaced by this HIE and HFEIB, and remaining all will be same your output side. Okay. So this is your H parameter model. Next thing is you have to find the gain. Since it is having a uh, shunt mixing, sorry, series mixing and then current sampling. So this is nothing but a transconductance amplifier. So what do you know about the transconductance amplifier? The feedback topology suitable for voltage transconductance amplifier is current sampling series mixing. The other name for this topology is series feedback. So the other name is series feedback topology or current series feedback topology. So for us, you all know for a transconductor amplifier, your input resistance is very high and the output resistance is very high. Okay. Input resistance is very high to the source resistance RS or the input resistance and it is also very high. Okay. So now first thing you have to find the transconductance gain. So how to find the transconductance? So GM is the transconductance gain. So how to find the transconductance gain is first apply KVL to the input side. So we have drawn the H parameter model. In that circuit, apply KVL to the input side. So applying KVL to the input side means the input current is same as the, since we are given input to the base, it is nothing but the same as the base current. So this is your input side. What is there are three resistance. So that potential Vs is equal to, for all the resistance, if you are considering it should be the voltage drop, it is the summation of, since it is series, Rs plus HIE plus Re into the current is IA, the same current is considered to be IB. So this is your equation. So Vs is equal to IB into Rs plus HIE plus Re. But transconductance is given by output current by input also, I naught by Vs. How to find I naught? Since we know Vs we have calculated, how to find I naught? So come to the output side. In this output side, you have this current I naught. Okay. So, but the current I naught is opposite to the collector current. The current I naught output current is opposite to the collector current. So it is nothing but minus HFE into IV. Why this minus HFE into IV? Because the current is actually it is equivalent to HFE into HFE into IC. So instead of this IC, since the collector current and the base current are same, so minus HFE into IB. So we have found out the value of I naught and Vs. Now substitute this value of I naught and this Vs in this equation GM. So substituting this the equation GM, you have obtained the value of minus HFE by RS plus HIE plus E. Okay, you have found. Next is to find the feedback gain. Okay, so how to find the feedback gain? beta is equal to feedback VF by I naught, you know. So mine, what is VF? It is the feedback across the resistance RE, since it is the feedback resistance. So it is, I told you, it is opposite to the output current. So minus I naught RE by I naught. So this value of beta is minus RE. Next thing is you have to find your input resistance, output resistance, desensitivity, all and voltage gain in terms of your transconductance. Okay. D sensitivity formula as per the negative feedback concept, D is equal to 1 plus beta GM. So what is beta? Minus RE. And what is GM? It is minus HFE by by RS plus HIE plus RE. So what is that? You have first all is 1 plus RE HFE by RS plus HIE plus RE as per things you have calculated. Okay, so we have found out. Now just cross multiply this equation with this, take LCM over this, you will be obtaining this equation. So from this RE and RE common in these two equations, so plus RE into 1 plus HFE. So what is gain with the feedback? It is gain with the feedback is GM by D. Okay, transconductance by the D sensitivity. So we have calculated GM, we have calculated D. Substitute both and cancel the common terms, you will be getting this equation. Now come to the next thing, voltage gain with feedback. So voltage gain with feedback is V naught by Vs, output voltage by input voltage. So what is V naught? I naught into RC, that is across the collector resistance by Vs, but I naught by Vs is your GMF, so it is GMF into C. So GMF you know, so GMF you have substituted and the value of RC you have used. Now come to the calculation of input resistance and output resistance. As I told in the starting itself, for a transconductance amplifier, the input resistance is high than the source resistance, and in output resistance is also high in the compared to the feedback. So it will be Ri into D. So actually Ri into 1 plus beta GM. Okay. So you know the value of 1 plus D sensitivity we have calculated, but how to calculate the input resistance you should know. So input resistance is the from this diagram. What is the input? So this is the input path RS, HIE, RE. So all are in series. So that is nothing but the addition of your RS plus HIE plus RE. So that is your input resistance RI. So you have to substitute over this equation. So now we have calculated that value also. And 1 plus beta GM desensitivity we have calculated. So you have to substitute over this. So that is your input resistance with feedback. Next come to the part output resistance with feedback. So R naught F is equal, since it is high, R naught into 1 plus beta GM. Already we know R naught is infinite. So R naught F is going to be infinite. What is R naught F dash is, so R naught F is without your collector resistance. Now what is R naught F dash is R naught F parallel RC, because the output resistance with feedback is parallel with your collector resistance. Since R naught F is infinite, infinite parallel RC becomes 1 by infinite plus 1 by RC becomes 1 by infinite is 0, so it becomes RC, since it is equivalent to the RC. So this is how you have calculated for your current series feedback topology. So the first step is the calculation of how to identify the topology. Second step is you have to calculate the gain. Third step is you have to calculate the feedback. And the third, next is you have to calculate the you have to draw the input circuit, output circuit, then the H parameter model, then the open loop gain, then the feedback, then the output input resistance, input and output resistance. So this is the simplest type way of deriving the current series topology parameters. The numericals, coming to the numericals, you can see that I have used one numericals with these values. So for calculating all this, you can directly apply the formulas. Okay. So for example, this is the circuit and you have the values here means, you know, GMF equal to GM by D. And this formula you have evaluated. So you have the HFE value, RS value, HIE value, RE value. You have to substitute over this and you will be getting the value of minus 0.015. And you know what is D? D is 1 plus beta GM. You know the value of beta. Beta so is minus RE. What is the given RE value? 1.2 kilo ohm. So it is minus 1.2 into 10 power 3. So what is D then? So 1 plus beta GM. GM you have calculated as minus 0.015. So you have this D equal to 19.18. Okay. Second thing is your GMF. So GMF calculated using the formula. Next comes to the point of AVF, GMF into RL. RL you have given. If it is given, you have to consider the RL value also. So GMF calculated into RL is 2.2 into 10 power 1, 10 power 3. You will be getting minus 1.72. And RIF, RI into D. RI is RS plus HIE plus RE. All the values you have. So it will be RI into D is RIF is given. Next, R naught, you know, infinite. So R naught F is infinite. R naught F dash is in the actual calculation, we are taken it as RC. Now we have, it is calculated as RL. So it is equal to RL. That is nothing but 2.2 kilo. Okay. So I hope you all have understand this current series feedback topology. Uh, Thank you.